Hello friends, let's have a look at problem 3325. Count substrings with key frequency characters 1. In this video, we're going to explain a solution based on the routine two-pointer sliding window strategy for this kind of problem. So the problem statement is very short. So here, given a string s and an integer key, we want to find the total number of substrings of s such that at least one character appears at least key times. So that's the problem statement. So you can see there are two examples, and so here the first example, so the letters can appear at least twice, right? So there's a 4. It actually lists all those. So in our solution, we are going to start from the complementary case, right? We'll make this clear. For the second example, because k equals 1, it means that at least one character appears at least one time. So this means that we just find all the non-empty substrings, because this length is 5, right? So you can have, let's use example 2. So the length 1 substrings are 5, right? The length 2 substrings like A, B, B, C, C, D, and D, E, this is 4, right? Then the length 5 strings is just 1, right? So what we get actually is 5 times 5 plus 1 over 2, right? This is 15. So this is the result. So this example is very special. Basically, we need to find all the non-empty substrings. So if you look at example 1 again, right? So the S is the same, but the K is 1 less. So what we want to do is that we find all the substrings where all the characters appear at most k minus 1 times, right? So if we can find this number, right, then we just need to use all the substrings, the number of counts for all the substrings, then minus this number. For example, in example 1, we know, right, all the substrings, the number of substrings is 15, right? So if we can find this number, all the substrings where all the characters appear at most 1 times, so this will be right 11. So then we get 4. So we need to verify this. So in other words, we will start from the complementary. We will find substrings where all the characters appear at most, k minus 1 times. So this is rather straightforward, right? So basically, we are going to do this for each right index, each index R. So we want to find left index L, such that so from L to R in this window, so all characters appear at most k minus 1 times. Then because of this assumption, then ending at index R, so we will produce, will yield, substrings. So from start and ending at R, right? So those substrings will satisfy this condition. But how many? So the start, the starter can be L plus 1, and it can be also R. So the end, all the end would be R. Then the counting will be R minus L plus 1, right? Then we notice that if we increase R, then because we want to make sure all the characters appear at most k minus 1 times, so the left corresponding to the current left will stay or increase. So This is the sort, overall sort. Let's see. So to carry out this program, and then we need monotonicity, right? Monotonicity to run sliding window. So this is the sliding window. So basically, in a mathematical formula, so if you have R, the corresponding L is L, right? So you have a large R, see R large, and then you also have an L large, right? So imagine you want to push R to the right. Then the conclusion is that L large will be at least as large as the previous L. In other words, we don't need to start over. So this is basically verifies that we can use sliding window. So this is our thought for using sliding window. So this is our idea. So we want to find out substrings where the characters appear at most cumulative runtime. So this is the sliding window validity, right? So with that said, we just need to carry out this program. Before we do that, we can actually work out an example. So this is the index. Let's see, we write here index, right? So this is the index 0, right? So ending at A, so you have 1. So index 1, so this is the AB, right? You can ending at B, you can start from index 0, you can start from index 1. So this corresponds to such indices, such substrings. So for index 2, so now we have 2 A's. We need to push L to the right, so we get BA. In other words, we eliminate this A. So then we have, you can start from B, you can start from A, contribute 2, right? And then for index 3, so we have BAC. So then you can start from B, you can start from A, you can start from C, all ending at C. So this contributes 3 valid substrings. So index 4, so you have BACB, but B doubles, so you just remove this B, you have ACB. So you can start from A, you can start from C, you can start from B. Again, contributes 3 valid substrings where the characters appear at most K-1, that is runtime. So the total is 1 plus 2 plus 2 plus 3 plus 3, that is 11. But we know the total number of substrings for a length 5 string is the length times length plus 1 over 2, that is 15, right? So 15 minus 11 is 4. So this is what we want to verify. So up to now, I guess we have explained the thought, and also we verified that we can use a 2-pointer sliding window method. And also we walked through example 1 in details. Now we want to look at coding. Once you realize this pattern, actually you can write the code in a very compact form. So first, let's write this length m s. So this is for convenience, right? Next, I'm going to get the total. The total means the total number of substrings for length for string s. So what matters is the n. So basically n times n plus 1 integer division by 2, right? So we can use a counter or a plain dictionary to carry information about each of the window. So let's use a counter. Let's see. So it's going to be collections counter, right? And then what we are going to do, so origin the left will be 0, right? Then for each r in range n, right? Then the count of the current character, that is SR, is incremented by 1. Then we want to check up to index r if there were characters which appears at least k times, because notice that we want the substrings contain each character with at most frequency k-1, right? So this is the basic while loop, right? So so because of the we have originally we have nothing, and then we add SR. So then the first character that can have this string is the current character, right? So in the process, we maintain every character appear at most k-1 time. So we just need to check for SG, for SR, right, the red character. If this is greater than or equal to k, then we are going to shift L to the right. So basically, count SL is decremented by 1, which means that we push L to the right. Then after we get this while loop, so then we are going to have that the count for every character is at most k-1. So in this case, we know it's possible that this this L is R plus 1, right? But the increment of this, let's see comp result, let's see, is 0. So we want to increment this one. This comp result is incremented by the number of valid substrings, in the sense that all the characters appear at most k-1 times. So we can start from L and ending at R. So then we can, which means that so L to R, we can start from, the starts can be L plus 1 and up to R, right? So the ends will always be R. In other words, we collect all the such substrings ending in R, such that all the characters appear at most k-1 times. Then this way, if we summation over R, we will get all those substrings, right? Then we just do some use this total minus this number to get the result. So this will be R minus L plus 1, right? You know, if L equals R plus 1, so this will yield a 0, right? That means that the logic is correct. So what we want to do is to return total minus comp result. Right? This actually is the main code. So let's do a test. It passes the first example. Now let's look at the second example, just to change this 2 to be 1, to verify that this will be 0, right? So let's see. Yeah, it passes the second example. Now let's look at the generic case. Yeah, it passes all the cases. Yeah, I would say that's basically about it for the for this problem. So here again, we're using a sliding window method. So actually we have a playlist which contains a number of other problems which can be solved using two-pointer sliding windows, but the difficulty levels vary. So you can also check out that playlist. With that said, I guess that's it for the current video. Thank you.